Okay, so question 9. I often say, guys, that I don't like to see a counting principles question towards the end of section A because I know it's going to be really difficult. But well, this one is difficult. I find once you see how it's done, it's not too bad. But in the middle of an exam, stressful situation anyway, obviously time is an issue. This is difficult. So we have 5 sheep called A, B, C, D, and E. Nice and easy to remember. They're being placed in these pens. Each pen is large enough to hold all of the sheep. Amber and Brownie are known to fight. Find the number of ways of placing the sheep in the pens in each of the following cases. So, part A. Each pen is large enough to contain 5 sheep. So, we can put them all into this pen. But Amber and Brownie, A and B, must not be placed in the same pen. Okay, so we're not going to put Amber and Brownie in the same pen. We can put, however, Curly, Daisy, and Eden into any of the pens. So think of it like this. Curly can go into any of the 6 pens. He can go into 6 pens. Daisy can go into any of the pens. So Daisy can go into 6 pens. Now you don't have to do 6 times 5 times 4 times 3 or anything like that, because they can both go into the same pen. So Daisy can go into 6 pens. Eden can go into 6 pens. And now actually I can put Amber, because it's only Amber and Brownie that need to be separated, I can put Amber into any of the 6 pens. So I'm going to times 6 again. But now I have Brownie, who I cannot put into any of the 6 pens. I can only put Brownie into 5 pens, because Brownie into 5 pens, because he cannot go into whichever one of these I put Amber into. Brownie has to go into a different one, and that's it. You can call that 6 to the power of 4 times 5, obviously, if you like. You don't even have to write that down, but just for my calculator, it's 6 to the power of 4 times 5, which is 6,480. 6,480. Part B. Each pen may only contain 1 sheep. Amber and Brownie must not be placed in pens which share a boundary, right? So that means if Amber goes in here, then Brownie cannot go in here, no Brownie, or here, no Brownie, because they share this boundary, or this boundary here. So we cannot put Brownie in either of those. Brownie could go into one of these 3, B, B, B. So with that in mind, let's, well, if in doubt, guys, there's a few fancy ways to do this I've seen on the mark scheme, but I like to use the method that makes the most sense to me. So if in doubt, you'd actually put Amber into one of these pens. So put Amber here. Let's say Amber is in this pen. Now, where can Brownie go? Well, Brownie can go into 3 pens. So it's 3. If Amber's in the first one, Brownie can go into any of these 3 pens. And then Curly can go into 4 pens, because let's say we put Brownie into this one. There's only 4 pens left, because in this question each pen can only contain 1 sheep. So if I put Brownie into one of these, Curly can only go into one of the 4 remaining pens, which means Daisy can only go into the 3 remaining pens, and Eden can only go into, hang on, am I right here? So Brownie can go into 3, Curly can go into 4, Daisy can go into 3, and Eden can go into 2. Yeah, that is correct. So 3 times 4 times 3 times 2. Or if you want to call this, guys, 3 times 4 factorial. This isn't, you probably do want to explain, guys, on the side what you're actually doing. So this is Amber in pen 1, if you like. Let's call this pen 1, 2, 3, 4, 5, and 6. Okay, so amber in pen 1. If amber is in pen 2, let me just get rid of this, guys. If amber, so now amber is in pen 2. If amber is in pen 2, the same situation, because brownie then can only go into this one, or this one. So brownie can go into 3, and then I have this same situation where 4 times 3 times 2 times 1. So this is going to be 3 times factorial. This is amber in pen 2. Now, if I put amber into pen 3, this is where it gets a bit different, guys. If amber is in pen 3, then brownie, if amber is in pen 3, then brownie can only go into, oops, if amber is in pen 3, brownie can't go here, here, or here. Brownie can only go there or there. So brownie can only go into 2 pens. So brownie is now going into 2, and again the other remaining 3 sheep can go into 4 factorial. They can go into 4 times 3 times 2. So this will be 4 factorial. This is amber in pen 3. Now hopefully, I like to do this until I start to see the pattern. So the pattern is, well, if I put A here, then brownie again can go into 2. So that's 2 times 4 factorial. This is A in pen 4. And then if I put amber here, it's like these first 2. Again, brownie can go into these 3. So now I just have 3 times factorial. This is amber in P5. And then 3 times 4 factorial is amber in P6. That's the same, because if you put amber here, brownie can go into these 3, and then again 4 factorial. So we're left with what are we looking for? The total number of ways they can put in the pens. So the total is 3 times 4 factorial plus 3 times 4 factorial plus 2 times 4 factorial is, I'm just going to add these up, 3 plus 3 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 16 times 4 factorial, which is 16 times 4 factorial, 384. So the total number of ways is 384. Okay, that's it. If you want to check the mark scheme, guys, for there's a few alternative methods that are arguably as easy and sometimes shorter, but this was my preferred method for part B. It was the one that made the most sense, and I thought, well, part A is hopefully not too difficult. Okay, that's it.